Hello everyone. Welcome back to the Glassman's World. I'm Dan the Glassman, and we are going to discuss the solar eclipse coming up here, April 8th, 2024. What is going on, guys? I don't know if you guys have heard about any of the stuff that's happening, what's going on with the solar eclipse and all these things, but there's talks going on about how you need to be prepared to have all of your vehicles full of gas and have them filled up and ready. Make sure you have all of uh, your food and water supplies on hand, and to make sure that you have alternative communicating devices. Why would we have alternative communication devices for a solar eclipse, guys? I don't know why they're telling us to prep for all this, why they're warning us. We necessarily here in Albuquerque, New Mexico, didn't get this warning. At least I haven't heard this specific warning here yet. But it's been coming from other places around the United States. And these are places that are in the direct path of the eclipse. So that's what we're going to talk about right now, is what's going on with this eclipse and the whole entire path of it. All right, so let's see if I can bring up some videos here. Maybe we can find a few videos that I've watched recently, and we can see. Let's see if I can find anything here. Okay, let's just go back to we'll go to history, because I do believe that I watched a video recently or last night or sometime, and it was a video explaining why it actually moves from one way to the other. Yeah, and it was a real simple video. So let's alright, so we're gonna check this out here. So this video, it's not my video here. I don't own the rights. I'm using it free use. It's been publicly displayed up here. And so I'd like to show and share it. It's from Free School, a YouTube channel here, so you can subscribe to them. Please subscribe to them if you like. The video is called "Why Does the Eclipse Move from West to East? Is the eclipse going backward?" Free School. And that's the video by Free School right here. So I'd love to be able to share this with you. Hopefully it's safe and it's okay for me to share this with you, and I don't get any sort of copyright infringement or anything, but sometimes that happens. So what I may do is maybe from time to time just pause it, and we'll take some breaks in between here and there. That way you can see what's going on. All right. So let's flip this around real quick. I got all this new buttons for this. They got this set up differently these days, guys. So everything is a little bit different now. All right, we're gonna set this up hopefully, and let's bring this up full screen and make sure that we got sound. And so this is what's called "Why Does the Eclipse Move from West to East? Is the eclipse going backward?" Free School. That's the video there, right? And that's what we're gonna watch right here, okay? And let me bring up the sound. And this is going to be the first time I'm going to be moving microphone to speakers, so we'll see if this picks up and if this works.
Even an amateur astronomer would be able to tell you that the sun and the moon both appear to rise in the east and set in the west. So why does the path of a solar eclipse travel from west to east? The answer lies in the way that the moon orbits the Earth. If you were positioned in space above the Earth's north pole, you would notice that the moon travels around the Earth counterclockwise. That is the same direction that the Earth is spinning, and the same direction that the Earth travels around the sun. However, the moon takes much longer to complete one orbit around the Earth, about 27 days, than it takes for the Earth to complete one rotation, only 24 hours. Although the moon is traveling much faster than the Earth is spinning, more than twice as fast, in fact, it has much farther to go. Because the Earth completes a rotation so much faster than the moon completes an orbit, the moon appears to travel from east to west across the sky, just like the sun and the stars. If the Earth were standing still...
So, you mean to tell me that the moon has to spin, it's got to go around that outside spin a lot faster. It's like, NASCAR races, and if you take that outside curve, usually the inside curve is the way to go to always be in the lead, right? So that just doesn't make sense. Like, for it to be faster and having to go way out there and spin, like, how is it locked into place in the first place to the Earth like that? And how is it spinning faster around the whole entire Earth, as the Earth is also spinning so fast, they claim? Alright, just wanted to ask that.
The moon would appear to rise in the west and set in the east, but very, very slowly. It would take the moon almost 14 days to cross the sky, then vanish for about 14 days before rising again. Let's illustrate why the moon appears to move from east to west with a familiar example. If you are on a train and pass by some people walking in the same direction, they appear to move backwards compared to you, even though they are traveling in the same direction you are.
Right. So for them to be the same speed as the train and keep up, to mimic what the moon is doing to the Earth, like, they'd have to be walking super fast, right? So how does the moon have so much trajection, so much velocity? How does it go so fast? That's what I am wondering. How is the moon so fast that it can spin around the Earth that quickly, like a slingshot? Like, it's spinning, like they're saying that the Earth is rotating very fast, but then as it spins around the sun, it takes 24 hours for it to finally reach around, the whole entire globe. So the moon then has to spin a lot faster than the Earth to keep up with it in that same rotation, but yet then staying kind of still looking with the sun. Like, oh man, it doesn't really make any sense. How are these things spinning and yet not creating day and night and day and night and day and night over and over again? It's so crazy. Like, I know they explain it the way they do.
A solar eclipse is caused by an alignment of the sun, moon, and Earth that causes the shadow of the moon to fall on the Earth.
Right.
To cause an eclipse, the moon must be in precisely the right position, but the moon is moving fast. It is traveling at a speed of over 2,200 miles or 3,600 kilometers per hour. The Earth is only about 7,900 miles or 12,000 kilometers wide, which is a distance the moon can cover in about 3 hours. Since the Earth is spinning at only 1,000 miles or 1,600 kilometers per hour, the moon's shadow will zip across the Earth before the Earth can spin very far.
Okay.
In other words, The moon only has to cross a tiny piece of the sky for its shadow to move all the way across the earth, from west to east, the real direction the moon is always moving. I hope this helped you to understand more about the motion of the moon and the path of the eclipse. Goodbye.
So the moon is always moving from west to east, but because it's moving so fast, we see it rise in the east and go up in the west. That's what she just explained, right? Did I think. Okay, did I understand that correctly? So she's saying that the moon is spinning so fast that it's actually going from west to east, but because it's spinning so fast and with the earth, that it looks like it's coming up from east to west. That's what I'm clearly hearing, right? And then they showed on that map right there how the trajectory of the moon, so right here, right, she's talking about this part.
1,600 kilometers per hour, the moon's shadow will zip across the earth before the earth can spin very far. In other words, the moon only has to cross a tiny piece of the sky for its shadow to move all the way across the earth, from west to east.
Okay, so we're going to see the path coming from here to there, right? Pretty much that's what they say. It's going to be coming from somewhere around here, going through Texas, New Mexico, and then coming all the way through and into Maine, like all this area, right? And then this is going to be the full eclipse, and then on the outside it's going to be like it's going to last for 4 minutes in a full, and then it's going to be 3 minutes a little bit here and 2 minutes a little bit here, and then it's going to be like partial, like 80%, then 70, then 60, then 50, and then all the way down to even to Florida. They're saying that it's even going to be like 50 or 40% that you'll be able to see the sun like get covered. But it's going to be timing here where I believe it starts at like 2 o'clock. And by the time it reaches here, it's going to be 3 o'clock. And by the time it reaches here, it's going to be like 4. And so I'm like wondering, okay, are we seeing it all at the same time? Because then that would mean that if this is the line, right, then the axis of the Earth, the North Pole would actually be facing this way, and the South Pole would be facing this way, right? If we're looking at the tilt, or would it be, hold on, I'm trying to see, no, actually, that would mean that the north would be that way. If this is the flat plane, and the sun being right there, the moon being right there, crossing perfectly in that flat plane as it's spinning, right? Then this would be the line, kind of like the equator, but not necessarily the equator, but the line, but maybe, like, that's the line right there, which then, that would be north, that would be south, to show that we're in an actual tilt. Right, because wouldn't it be coming straight this way? Like they're like that's why they're showing their model is coming more at that angle, right? To where then you can go north and south, and these lines are a little bit more even right here, right? But this is going to be crisscrossing this way in a complete X. Like if the Earth is tilted its axis or something, I don't know. Can anyone please explain this to me on how, I mean, I understand that this is the East Coast, so right now, if we are at whatever time it is, 7:15 in the morning right now, right? it is already 8:15 here and 9:15 here, right? So when you're seeing it in different times, like, is it that we're seeing it in the different time zones, or is that this is you're seeing it in 2 o'clock Mountain Standard Time, which would be 4 o'clock Mountain Standard Time over here, 3 o'clock Mountain? Like, is that how it's working? I'm not sure. I need to have someone explain this to me a little bit better. This video is trying to explain it, but then for them to even explain how the moon has to rotate a lot faster around the entire planet, and like to even be able to keep up. Like, imagine doing that. Like, there's a center rotation, right? And you got to try to spin. Like, okay, think about those old school kids. Uh, what are those spinning? Not a Ferris wheel, but the merry-go-rounds, right? Those old metal merry-go-rounds, right? You have the handlebars on them. You run around, run, and boom, fling them going, and then all the kids are like, hanging off the sides, and they fly off, land in the sand or wherever they land, right? Like, that's the reality of those things. That's why they got rid of them, because they were so crazy and dangerous. Kids would just be flying off them and broken bones all the time. So, or kids would get caught up underneath it because they'd climb underneath for some reason, right? As it's spinning, and then they'd get all messed up because that thing couldn't stop the rotation, right? They'd bang their head or whatever. Like, don't climb under there. So, think about trying to like spin, and then that thing's going so fast. Now, try to keep up in the rotation on a further orbit than what you just spun it at, right? And try to like keep up and go a little bit faster to be the moon. Like, that's what they're saying happens with the moon. The moon spins around that much more faster than what the Earth is doing, and then it'd be like the merry-go-round is spinning like that, right? As the moon is also going a lot faster, like the person running around it, right? And keeping up are also going faster, right? And then you got that merry-go-round spinning, but it's rotating around the whole entire park, and there's like some sort of light fixture in the middle, like like a light tower, right? And your merry-go-round's going around that light tower. That moon's got to go like this. And maybe it is. Maybe it is. But I'm just like, wow. It's doing that, and it's staying still. It doesn't even have its own rotation. Like, that's wild. Even from the moon, you're seeing the Earth rotate, right? As you're spinning around it. That's pretty interesting. So, I don't know how that works. How they're going to see it at 2 o'clock in Texas and New Mexico, and then it's going to move towards the East Coast. Like, no matter what the moon is doing, shouldn't the sun always be coming from this way? And have we always seen the eclipses going the other way? Like, I guess so, because they're showing the direction of it here, and in this map right here, it's the direction of it. It's showing it, and I guess that's where it's going. I don't know. I'm gonna leave y'all with that. Can someone please explain this a little bit further for us all to understand how this works? Because it don't make no sense to me. But I'm just a glass blower here. Some things I can really understand, and some things are just like, I don't understand, unless that's not how it works, and there's a whole different model on how it all works, and maybe flat Earth theory is real, and maybe the sun and the moon are actually locked in over here above the entire Earth, and they're locked in right here, and they're the same exact size, and that's why somehow they can block each other out. Or is there a third entity within there that somehow blocks out something and comes within that center to then perfectly block it all out? We're going to keep track of the moon. When I woke up this morning at about 4 a.m., the moon was actually setting, I believe, or was that last night? I'm going to have to check where the moon is tonight, but we're going to start following the moon. Actually, I believe that was last night when I took out some trash, and we're gonna follow this. We're gonna see where it was, but I'm wondering if it was this morning, actually, right before I got on the torch at like 5 a.m. And I think so, because it was still dark outside. I believe the moon was just setting to the west, so we're gonna see where it is tonight and when it's setting, and we're gonna follow it, because one thing that I've noticed is as soon as the moon sets, it's like the sun is coming up. And I'm like, wait, if we are on a complete total globe, right? If we're on a whole globe, and like if the moon is just barely setting, like the sun and the moon have to be like coming up and setting at the same exact time almost, right? I guess. I don't know. I guess we're going to be going into a new moon where we won't see the moon, but then it's going to come into light. Is that how that works? Because the full moon is when it's way over here on this side of the planet, and the sun's over here, and the Earth is right here, right? Earth is here. Full moon is like probably not right directly behind, because then that would be an eclipse where the Earth would eclipse the moon, right? And that becomes a new moon where it's gone. But then once it's out over here, then it's more lit. While the sun's over here, the Earth is a little bit over here, right? And then as it's rotating, then eventually that moon comes into place where the sun, like let's say that's the sun, right? And then the moon comes into place finally. Let's say my head's the Earth, right? And the moon is spinning around the head, right? Boom, 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 spinning, spinning, spinning. Eventually that moon has to come over here, right? And then block the sun, right? So the sunrise and the moon rise have to be at the same exact time. So we're going to have to follow where the moon is and location with the sun. Because sometimes when I've seen these eclipses, I've been like, wait, didn't the moon just set, but now the sun is just coming up? Like, shouldn't it be on, like, how did it travel all the way back around real quick? Like, wait, that don't make no sense. But that's just me, and I don't know, maybe I'm just seeing things, maybe that was the Earth getting in front of the sun, and I was not understanding things, but I don't know. I could be wrong. Let's, someone comment below and please explain to me though on why we're seeing it at 2 a.m. or 2 p.m. in Texas, New Mexico, and it moving. The sun is moving, I think, from the west to the east, or at least in timing. They're going to be seeing it in later timing. 2 o'clock here, 4 o'clock in the east. How does that work? I know that there's time changes and time zones, but then that means that the sun is like, I don't know. It's not making sense to me. Someone comment below. Let me know what you think. Thanks for watching. I'm going to go get ready to get some work done today. Got to go do some more yard work, so we'll see what the sky looks like. Looks like it's blue sky right now. I don't see any heavy aerosol canvassing yet. We will keep track of that as well. And we will also keep track as we get closer to April 8th on what the skies look like, if they're going to keep them clear or if they're going to cover it up to where we can't even see the eclipse at all. Because that'll be interesting as well, if they just cover it, make it look completely overcast and we can't see anything. Because they can do that, right? Alright, thanks for watching. I'll talk to you soon.